The second scenario is when you're given an equation that has logs already in it. So we want to start again by first simplifying until we get one term on each side. And you might need to use those log properties from the previous couple slides to get that to happen. So you might need to use the product property or the quotient property, something like that. Once you do that, we can use inverse operations, and you just want to make sure that you check your answer. Remember we discussed that the argument must be greater than 0, so we always want to substitute our answer back in and make sure that that is the case. So let's take a look at this example here. Here we have one term on each side already, so that's great. So we have log base 3 of 4x minus 17 equals 5. So we have a base of 3, we have an argument of 4x minus 17, and an answer of 5. So we need to solve for x. So right now, x is within an expression, and we've taken log base 3 of that expression. So to undo that, we need to raise it to the power of 3, and we need to make sure that we're doing that on both sides. Just like when we're solving a linear equation and we add 3 to both sides, or divide by 3 to both sides. We want to use the same number. And now, on the left-hand side, we've done inverse operations with the same base. Now we just have 4x minus 17, and we can simplify that 3 to the 5th. Now it's just a linear equation to solve. We can add 17, divide by 4, and there we go. Almost, at least. We do need to check to make sure that when we substitute that 65 in for x, it doesn't make the argument negative. So the argument is 4x minus 17. So when we substitute in 65, it definitely does not make it 0 or negative, so we're good. So x equals 65. That is our answer. You want to make sure to circle or box that on a test so that your teacher knows that you know that is the answer and there's no extraneous answer. Let's look at a second example. Here we have 2 logs on one side, so we need to condense that into 1 log. So we can use that using our quotient property. One of the most common mistakes I see when I'm grading tests and quizzes is that students forget that when we use the quotient property, we just have 1 log base 8. We don't have a log in the numerator and denominator. It's just log base 8, and we're taking the quotient of those arguments. Now we have one term on each side. We're taking the log base 8 of that expression, so to undo that, we need to raise it as the exponent of 8. So that entire expression is now the exponent of base 8. And again, notice I've done that on the right-hand side because I have to balance the equations. I've got to do it on both sides. Now I've done inverse operations. They cancel each other out, not only on the left, but also the right. And so now my logs are gone. They didn't just magically disappear. They're gone because I used inverse operations to cancel them out. Now I've got this rational expression to solve. Cross multiply, distribute, simplify, and there we go. And we're not done yet. We still have to check to make sure that that 2 doesn't make the argument 0 or negative. So let's check that. So my arguments are x plus 10 and x minus 1. So if I substitute in 2 for x, I get 2 plus 10 and 2 minus 1. Both of those expressions are greater than 0, so we're good. My answer is x equals 2. So again, you want to make sure, I would highly suggest that you go ahead and you circle your answer on a test or a quiz so your teacher knows for sure that you know that that is the answer. It doesn't make the argument 0 or negative. Here's another example. Again, I've got 2 logs. I need to get that into 1 log so that I get 1 term on each side. And here I can use my product property. Here it's going to be a little more difficult. I'm going to have to recall some Algebra 1. I'm going to have to distribute, multiply those together. But once I do that, I can then use my inverse properties. I'm taking the log base 8 of that expression so I can raise it to the power of 8, and notice again that I do it on both sides. Once I do that, the log and the base of 8 cancel each other out because they're inverses, and I'm left with just that quadratic expression, and on the right hand side I can simplify that to 8. Now I have a quadratic to solve. Subtract 8 from both sides, factor, set them equal to 0, and solve. Now in this case, my arguments are n minus 3 and n plus 4. I need to make sure that negative 5 and 4 don't make that argument, either one of them, 0 or negative. So when I substitute in negative 5, both of the arguments are negative. So we definitely throw that one out. When we substitute in n equals 4, it makes them both positive, so n equals 4. That is my final answer. Again, make sure you circle that. Make sure it's clear that this is your answer, not this one. Here's another example. I have a natural log, but don't let that throw you off. Remember, that is just log base e. I have one term on each side, so since it's log base e, I need to raise it as the exponent of e. So that entire expression is now the exponent of e. So e to the log base e, inverse operations with the same base, they cancel each other out on the left. I've got x plus 3. Now, I don't know what e to the 5th is. I definitely need a calculator here. But notice I haven't touched my calculator yet. You don't want to touch your calculator until the very last step. I still need to subtract that 3. Now I put it in my calculator. And I want to check to make sure that the argument of x plus 3 is greater than 0 when I substitute in 145.413, and it is, so we are good. So this is definitely our answer. So that's all I have for this presentation. I will be adding some more videos shortly, and I'll be adding some more videos of me actually writing stuff out, and also videos of me in person writing on a whiteboard. So stay tuned, more is to come.